I wasn't really impressed with the answers I got the time I gave an exercise on the preparation of salts, specifically on the preparation of insoluble salts. Even on the soluble salts, people are still struggling, but I had to demonstrate a practical on it, and I feel people need to revise, we need to read. So, on the preparation of insoluble salts, it's you to tell me the type of salt we're going to prepare. Just after I show you the reagents, you have to tell me the type of salt that we're going to prepare. So it means you're going to write the chemical equation on your own, then in a minute time, you tell me what salt we are preparing. So with me here, I have, I don't know if you're able to see. Are we able to see?
Yes, we are.
So what is the name of that salt?
Minema.
Minema. My name.
I want you to read.
No.
I want you to read what is here.
Barium nitrate.
I want you to read what is
barium nitrate.
Barium nitrate.
Barium nitrate.
Nitrate. So we have barium nitrate. If you can write somewhere barium nitrate, the formula is there. I don't know if you're able to see the formula. The formula is there.
Yes.
So that is barium
Yes, sir.
nitrate. I hope you have taken note. Then the other salt is zinc sulfate. Are we able to see?
Yes.
Yes.
So the other salt is zinc sulfate. And the formula is right there. So the formula is right there. ZnSO4. So those are the two reactants. Those are the two reactants that we have. So basically what we're going to do is we're going to make a solution of barium nitrate. So this is my zinc sulfate that I'm going to put in there. So those are zinc crystals. So I'm going to make a solution of zinc nitrate. So you're going to tell me the salts that I am making and the nature. Is it soluble? Is it an insoluble? So that is just water. That is water. So you can stir so that you have it uniformly dissolved in the distilled water. So this is zinc. This is my zinc sulfate. Then allow me to prepare the barium nitrate. So that is my barium nitrate. Just break those crystals into powder. So what salt are we forming? Looking at those two reagents. When you put those reactants together, what product are you getting? Or what products are we getting? So I'm adding water to this. I'm interested in the products that we're getting. What products are we getting? You have zinc sulfate plus barium nitrate.
Zinc sulfate and barium nitrate.
Yes. What product are we getting? Or what type of salt are we preparing?
Zinc. Its name has gone.
Zinc.
It's zinc something now. The last part. Is it zinc nitrate? Is it zinc nitrate?
Zinc nitrate and
Barium
have
nitrate.
zinc sulfate, which is
Zinc
in
sulfate
aqueous,
and barium nitrate.
aqueous
It's in aqueous
and
state.
barium nitrate in aqueous state.
Aqueous.
So what are we getting?
Barium.
That's your name. Hey, the girls are just quiet. Sir.
So this is what we're going to get. Zinc sulfate, which is in aqueous state, reacts with barium nitrate, which is in aqueous state. We are interested in the insoluble salt called barium sulfate. And then we're going to have another soluble salt, which is zinc nitrate. So this is,
okay, I said zinc nitrate, but not barium.
this is the preparation of an insoluble salt.
Substance.
Preparation of an insoluble salt. And barium sulfate happens to be the insoluble salt in this equation. So this is how we prepare barium sulfate. If you read the notes, I told you that you need two soluble salts. So the two soluble salts, the two soluble salts are the ones I have here. Barium nitrate and zinc sulfate. These are the two soluble salts. According to the rules, or according to the requirements, you need two soluble salts that you're going to mix together, isn't it?
Yes.
So you mix together, then they are going to form a precipitate. That's what we said. They are going to form a precipitate of an insoluble salt, isn't it?
Yes.
Exactly. So those are my two soluble salts. These are my two soluble salts. So I'm going to mix them. So how do I mix? I get this other one, I put it in. So I get the barium nitrate, I put it in the zinc sulfate. So just notice what happens. I hope you're able to see. What have we
looks
observed?
like milk.
What have we observed?
Milky. It looks milky.
It looks like milk.
It looks
like milk.
Isn't it? So
yes,
what happens is when we give it time, hopefully we can manage to. If we can give it some time, we're going to notice that there will be what we call a precipitate. Something will settle at the bottom as insoluble, then we're going to have a clear solution on top. So we're going to have two layers. So if we give it time, just to observe. We give it time. We're going to have some white substance that will settle at the bottom. So the white substance that will settle at the bottom is the precipitate called barium sulfate. And then what will be on top is the soluble
zinc
nitrate. Exactly.
Yes, sir.
Yeah. So we'll give it 5 minutes. We'll give it 5 minutes and observe what basically happens. Then the next step will tell you that you have to use a filter paper and a funnel. Then you separate the two salts. So we know how to fold the filter paper. So we fold the filter paper as usual. Then we put it on the funnel. So we put it on the funnel. Then we'll use the other beaker to separate. Use the other beaker, probably this one, to separate. So logically, what is going to remain on the filter paper is the barium nitrate, which is insoluble. And then what will go through what will penetrate through the filter paper is the zinc nitrate. So you're going to have the zinc nitrate in the container, and you're going to have the barium sulfate as a residue on the filter paper. Then thereafter, you just get your filter paper, you dry it, and then you have the crystals of barium sulfate. So it means that you have prepared barium sulfate. So let's give it time to settle so that we just see what will be down there and then what will be up there. We just observe the two layers. But I'm sure even at this point we're able to see the layer, isn't it?
This is starting to separate.
Yeah, so what you have down there is the barium. So what you have down there is barium sulfate, and what you have up there is the zinc
nitrate.
Exactly. So that is basically what happens. So from there you can pour your mixture on the filter paper. So this will take some time. This will take some time, as you can see, it's just there. So you make sure that you have a homogeneous solution, and then you filtrate. So because it's a demonstration, you're not going to pour everything. We just allow a few to. So basically what we'll have here in the beaker is the zinc nitrate. Then what will remain on the filter paper is the barium sulfate. I hope it's clear. Unless there are questions.
Very much.
Yeah, unless there are questions or clarification.
So can this come as a question in a practical paper?
Yeah, this comes as a question in a practical paper in most cases. And even in the final exam theory, they can ask you, describe, the same way I asked you, describe the preparation of an insoluble salt barium sulfate. So this is the description that I was looking for. So you get two soluble salts. So you have to tell me the names of those soluble salts, looking at what salt you're going to produce. So if I'm going to produce barium sulfate, it means that I need zinc sulfate and barium nitrate. So I'll make a solution of these two, then I will mix, then filtrate, then the insoluble salt remains on the filter paper as a residue. Then that residue is allowed to dry, and then I'm going to have crystals of barium sulfate. So basically that is the explanation that I was actually looking for the time I asked people to describe the preparation of these particular salts. So they are very important questions, and you frequently find them in examination past papers if you go through the past papers. So it's a requirement that we have to know how to describe, how to prepare both insoluble and soluble salts. So I felt I needed to revisit this component and talk about the preparation, unless there are questions on this part. Questions?
No, so that was a beautiful demonstration. It was clear for me.
Yeah, so we'll notice we'll have the insoluble remaining on the filter paper as a residue, and then the soluble will penetrate the funnel, the filter paper, and will obtain it in the other beaker. So basically that is, I sent the notes that talks about what composition of these soluble salts you need. So if you're preparing barium sulfate, you're not only restricted to using zinc nitrate. The idea is, if I'm preparing barium sulfate, one of the soluble salts should have a barium, then the other one should have a sulfate. So I gave those details in the notes. If I am preparing silver chloride, it means that one of the soluble salts should have a silver, and the other one should have a chloride, so that when they are put together, the silver from here will jump and join the chloride from here, so that they form the insoluble. So our responsibility is to go back to the classification of salts. How do we classify salts? So I gave a table. We said for soluble salts, we said all nitrates are soluble. Any salt that contains a nitrate, be it potassium nitrate, silver nitrate, barium nitrate, so long as there's a nitrate at the end, it's a soluble salt. And we talked about how to prepare a soluble salt. Then, any salt that contains a potassium, it contains a sodium, it contains ammonium, we said it's a soluble salt. So any salt that starts with a sodium could be sodium chloride, sodium sulfate. Any salt that starts with potassium, any salt that starts with ammonium, we said they are soluble. I believe that table is there. It's just a matter of perusing through and getting accustomed to what is being talked about. Then we said insoluble salts, all carbonates are insoluble. Of course, there are exceptions which are mentioned. Then all chlorides are soluble except silver and lead 2 and mercury. So we have to know which ones are insoluble and which ones are soluble. So it's after you know the nature of the salt, then you can prepare that particular salt. It's very logical. Like I always say, you can only prepare a salt after or before you understand its nature. You know the nature of the salt, then you know the methods to go about when it comes to preparations. So it's as good as they tell you to prepare, they ask you to bake a strawberry cake. Ask you to bake a strawberry cake. It means that on your recipe materials, you need a strawberry, isn't it? You cannot bake a strawberry
Yes.
cake and then you don't have strawberry
without
in the raw materials. So it will give you a clear guide on what method you should embark on when you know the type of salt. It would be so wrong of you if they ask you to prepare an insoluble salt and then you use a method of a soluble salt. It means that it clearly shows that somebody doesn't understand. So why we emphasize on understanding the nature or the class of the salt, it's because that is the knowledge you're going to use to help you prepare that particular salt. So if they ask me to prepare barium sulfate the way I was preparing barium sulfate, I cannot use any other method apart from this method. So my knowledge will guide me on which method I should use. If I use a titration in this method, then clearly it shows that I don't understand what I'm doing. So it is very important for us to understand the nature of the salt that we're about to prepare, and it will guide us on what particular method. Are we using a precipitation method or are we using a crystallization method? So it's very key for us to understand the nature of the salt. Is it clear?
yes, sir.
Yeah.
So from there, we'll be required to talk about oxides. So we have what we call oxides. We have what we call oxides. So this book comes with all the content. I shared this book. If you just make proper use of it, you will benefit. It comes with a lot of content. So we have what we call oxides. So oxides, these are just substances that we get when a compound reacts with, or when an element combines with oxygen. When an element combines with oxygen, we have what we call an oxide. So this element can either be a metal or it can be non-metal. So we have 4 types of oxides. We have what we call a basic oxide, an acidic oxide, an amphoteric oxide, and a neutral oxide. So when you read those notes, they will basically talk about those types of oxides. So as you can see on the screen, we have acidic oxides, basic oxides, neutral oxides, and amphoteric oxides. Just to make it easier for you to understand, when they say acidic oxides, they say these are oxides of non-metals. When a non-metal, you go on the periodic table, you put the zigzag line, you know where to find the metals and where to find the non-metals. So when a non-metal combines with oxygen, we call it as an acidic oxide. When a non-metal combines with oxygen, we call that as an acidic oxide. Is it clear? So they'll give you examples. Sulfur combines with oxygen, you get sulfur dioxide. Nitrogen combines with oxygen, you get nitrogen oxide. Phosphorus combines with oxygen, you get phosphorus 5 oxide. So what happens is when those acidic oxides come in contact with water, they form an acid. So that is what is being explained right there on the page that we're looking at. So sulfur dioxide combines with water, you form what is known as a sulfurous acid. Then sulfur trioxide, which is SO3, combines with water, you form sulfuric acid. That is where we talk about acid rain. If you remember back then in grade 10, when sulfur dioxide is released in the air and it comes in contact with the rainwater, it's going to produce acid rain. So we call them acidic oxides. Then we have, I'm sure you make use of the notes to get a more depth understanding. Then we have basic oxides. Basic oxides is when a metal combines with oxygen. We call them basic oxides. So basic oxides, when they are dissolved in water, they form an alkaline solution. So on the characteristic properties of basic oxide, that is what they are basically talking about. So a metal combines with oxygen, you form a basic oxide. The basic oxide dissolves in water, it forms an alkaline solution. That is what they are talking about and demonstrating in that experiment. Then neutral oxide. Neutral oxides, these are oxides that do not exhibit properties of acidic and basic. They are neither acidic nor basic. They are just neutral by the name itself. So this is water, carbon monoxide, nitrogen monoxide. Those are the examples that are being given there. Then we have the opposite of neutral oxides that are called amphoteric oxides. Amphoteric oxides, now they have both properties of basic and acidic oxide. So that is why you find aluminium oxide, zinc oxide, and lead 2 oxide. So I thought of talking about these because they are very important and they come in an exam. They can ask you, can you state an example of an amphoteric oxide? Or what is an amphoteric oxide? What is a basic oxide? What is a neutral oxide? So it's very important for us to understand these oxides. Then I gave you in the assignment to describe deliquescence salt, efflorescence salt, hygroscopic salt, hydrous salts, and hydrous salts. So those details, you'll find them in this book. They are clearly described. So all the preparations and whatever, you find them in this book. So I just thought of making it easier for you to understand by just demonstrating. So they explain clearly what happens, how the ions exchange themselves and you form the insoluble. So anhydrous, as you can see, they've talked about anhydrous. What is anhydrous salt? What is a hydrated salt? So I think people just need to make use of the book, and you definitely get the details. I hope my demonstrations were clear.
Very.
And my explanation made sense.
It did, sir.
Yeah. So I know it's a tough time, and we are called to be more responsible. So the learning will be done in briefing. So we have to take up the role and be more responsible. So where we don't understand, let's endeavor to ask. So we'll be coming in, we demonstrate on a few concepts, but entirely it's on us to dig deeper and get the understanding of the concept. So we try to make them as easy as we can when we have the opportunity. So invite others next time so that we will be moving at the same pace, because it's very difficult when you have a small number. But I have recorded the video, so we'll see if we can post it somewhere so that people can
I
actually,
think just post it in the group, sir.
yeah, so that people can actually benefit from it. But it's very important that you make yourself available, and it'll be easier for you to learn. So
Yes, sir.
until next time, for those who need a copy of the book, the books are still available. You can get it either from here at school or when I'm home. So make arrangements. It's something which is very helpful for those who have the copy. I'm sure they can testify. It's something that will help you revise the concepts and connect them to what we are looking at the moment. So until next time, for those who feel they should get in touch, my WhatsApp is always on. You can get me on WhatsApp. So until next time, we say our bye-bye for now.
Okay,
Stay
sir,
safe, sir.
bye-bye.
All right, have a wonderful day.
Same to you.